Good morning, everybody. Welcome to Overcast and Cold Friday morning on Chem 1105 with your host, me, Dr. White. Howdy. All right, important thing I want to remind everybody about is not my phone. Hold on. Nope, it's not the governor of the state of Illinois. Forget it. All right, stop. Oh, it listened to me. All right, important thing. Last week, I mentioned that I will now be strictly following my syllabus concerning the lab. The lab, and I graded it this morning, that was due Tuesday. If you don't get it in by next Wednesday, you will get 0. Yes, 0. Big 0 points. So even though you're handing it in a little late, it's better to get some points than 0 points. So be sure to hand in your labs. And with that, I'm going to get started. Remember, hand in your labs. I want you to succeed, and you're not going to succeed if you don't hand in your labs. All right, most of you are, though, but there's a lot of you who aren't. And you know that's blueberry tea. It is. All right. Keeping with what I was working on Wednesday, I'm going to do one more practice problem with gases. And we're going to have some fun, at least chemistry fun, like Dr. White can, with PV equal nRT. And after that, we'll start the next chapter. Yay. All right. Thumbs up, people. Can you see this? Thank you, Mackenzie. All right. Let's do the following problem. And let's have some fun with PV equal nRT. You probably don't know, but I'm going to teach you now. When you burp, most of your burp is carbon dioxide. So and carbon dioxide in your burp is a gas. So let's have fun with a burp. And notice, yes, 15 points. And the body temperature in Celsius is approximately this. And hold on. There, for those who can't read script or cursive, not script. But anyways, if you burp 2.00 grams of CO2 at 37 degrees C and and 756 torr, all right, let's have some fun. If you burp 2.00 grams of CO2 at 37 degrees C and 756 torr, then what is the volume of your burp? Bet you never thought I'd get into burps in this class. You'd be surprised what other things are still left that I can get into. All right. Now, if you look at this, what are we being asked to find? A volume. What are we given? 2.00 grams of a chemical, CO2. We're given a temperature. And we're given a pressure. Now, if you notice right here, we're dealing with a gas. Carbon dioxide is a gas at these conditions, and none of the parameters, volume, temperature, weight, or pressure are changing. Immediately, that should tell you you should be using the ideal gas law, PV equal nRT. And something I forgot to open, which I'll do right now. And if you look at your screen right now, oh, I've never said that before. Or look at your monitor. I guess they're synonymous or synonyms. Ooh, fancy word today. The ideal gas law, you find in important information, test number 3, PV equal nRT. Now notice, pressure is in atmospheres, volume is in liters. You don't have to change that for this problem. N is moles, and temperature is in Kelvin, and also R in PV equal nRT equals the universal gas law constant, which for this class, I'll use 0.0821 atmospheres liter mole K. And this is a calculated number, and therefore the one we use has 3 significant figures. Now, also in important information, 760 torr equal 1 atmosphere, also equals 760 millimeters of mercury. But 760 torr equal 1 atmosphere. And that's where I've been cutting down on what you have to learn. So what are we trying to solve for here? Volume. So what I'm going to ask you to do is right now solve for volume. Don't put any numbers in. Just solve this equation for volume. Your turn to have some fun. Not asking you to do the whole problem, just solve for V using this equation. All right, let's get going. If I have PV equal nRT, and I want to solve for V, because that's what we're being asked to find, I want it alone on one side. So how do you get rid of the pressure P? Remember, anything divided by itself equals the number one, meaning it cancels out. So I'm going to divide this side by P. Whatever you do to one side, you have to do to the other. Now, P divided by P is 1. 1 times V is V. So volume equals nRT divided by P. Now, what's N? N is moles. Well, oh no, we've got to wait. And if we want to get to moles, to convert weight to moles, what do? Well, it's time to look at important information, test number 3. And 1 mole of a compound, and CO2 is a compound, equals the molecular weight of that compound in grams. And the molecular weight of the compound is the sum of all atomic weights. So remember, 1 mole of a compound equals the molecular weight, and the molecular weight of a compound equals the sum of all atomic weights. And it's time for a commercial from your host, me, Dr. White. If you're having problem doing what I just said, don't forget this last Tuesday, after we did the lab at the beginning, I went through mole practice problems. The video is up in my YouTube channel. You know, Dr. White's a YouTube star. I am, not really. But anyways, go back and look at that. You're going to need that for test number 3, big time. All right, so it's time to use your good buddy, your good friend, unit analysis. I love doing that. And how do we do that? Whatever we're trying to get to goes on top of the ratio units wise. Whatever we're trying to get rid of goes underneath. I'll write those in. And where do I get this relationship? 1 mole of a compound, in this case CO2, is equal to the molecular weight in grams of that compound. So we now have to do the molecular weight of CO2, and it's 1 carbon, 2 oxygen. If you go to your periodic table, underneath the element, you'll see for carbon to 3 significant figures is 12.0. For oxygen, underneath the symbol O, the 3 significant figures is 16.0. Do the math. Add them together. And notice when you do an addition, you get the same number of significant figures to the right of the decimal that the number that has the fewest significant figures to the right have. Both are 1, so it's 44.0. And now I'll get my calculator, turn it on, put some light in it, turn it on, clear it. And my calculator gives me 4.5454545454 times 10 to the minus 2. And I'm going to round that off. So we have that number. So we got moles. R is the universal gas law constant, which is an important information. Test number 3. And next we have to do, we have N, R, next is T, but T temperature has to be in Kelvin. And temperature in Kelvin equals degrees C plus 273 equals 37.0. And I could have left off the 0.0 plus 273. And this would be equal to 310 Kelvin or 310.0 Kelvin. And so we now have T, and now we're left to do pressure. And pressure has to be in atmospheres. But we have 756 torr. And we want to get to atmospheres. So we'll use our good buddy, our good friend, unit analysis. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. And where do we get that? From important information. Test number 3, 1 atmosphere is equal to 760 torr. Now, please note, these are both exact numbers. This is 3 significant figures. Oh, by the way, this was 3 significant figures. And this was 3 significant figures, which is why I rounded off. And therefore, our answer should be 3 significant figures. And once again, I'll clear my calculator. And my calculator gives me a number 9.94736.842 times 1 times 10 to the minus 1. I'll round that off to 3 significant figures. And am I done? No. I now have to put in the values. All right, for N, we got 4.55 times 10 to the minus 2 moles. R is 0.0, and this is given to you in important information. Test number 3. And temperature and finally pressure And before I go ahead, notice if we forget about the bottom, moles cancel out moles, Kelvin cancels out Kelvin. We're left on top with atmospheres, liters, divided by atmospheres. So this cancels out, and we're left with liters. So that's volume. We're on the right track. And now I'm going to put those numbers in my calculator. And the number my calculator gives me is 1.1638, et cetera, times 10 to the 0. And I'll round that off to 1.16 liters of CO2. So if you burp 2 grams of CO2, you're going to, the volume of that burp is 1.16 liters. If you think about that, that's going to be a monster burp. Your lungs have a capacity, I looked it up last night, I cheated, of about 5 to 6 liters for an adult who has healthy lungs. And if you do 1/6 of that, that's going to be a monster burp. You're going to shake the neighborhood. But the next time you're at a party, you can tell someone, you know, if you burp 2 grams of CO2, that's about a little over almost 1.2 liters. Think of that. You know, the 2-liter bottle of pop, that's more than half of that. Wow, that's going to be a big, loud burp. I bet you didn't think you could have fun with chemistry. You can. All right. Any questions on PV equal nRT? Remember, 15 points. All right. Since there are no questions, guess what time it is? It's new chapter time. And what's that new chapter? It's solutions. Thumbs up, people. Do you see solutions on your screen? Thank you, Ruben. All right. Now, what's a solution? Well, good question. Well, there's 2 ways of describing it. One is a mixture which one substance is uniformly dispersed in another substance. Another way, which I like, which is why I put the second one, first one's from your book. A solution is a homogeneous combination of 2 or more substances in which each substance retains its own chemical identity. Now, in case you forgot, homogeneous means the same throughout. And remember, a long time ago, we talked about homogeneous mixtures. And at that time, I could have said those are solutions, but I wanted to wait until, and again, in case you're wondering, if you're reading a book, we're doing chapter 5, part 2, that a homogeneous mixture is also called a solution. Now, solutions play a very important role in our everyday life. How important? Well, I'll tell you in a second. But first, there are 2 definitions you should know. Time for Dr. White to be subtle. And those 2 definitions are names or important names. One is When we talk about solutions, there are two parts to the solution. One is called the solvent, and the solvent is the component present in a solution in the greatest amount. Again, the solvent is always defined as the component of a solution that's present in the greatest amount. Now, all the other components, and it can be more than one, are called the solutes. And the solutes are a solution component that is present in a small amount, or I could have also written a smaller amount relative to the solvent. So you should know what is a solvent, what is a solute. And we're going to practice this in a second, but let's talk about some types of solutions. Then we'll go back to solute and solvent. Well, you can have all types of solutions. You can have gaseous solutions. I bet you didn't think right now you're sitting in a solution. So am I. The air around us, you can't, well, you can feel it blow or go like this. You can feel the air, and that's a solution. It's a mixture of oxygen and nitrogen mainly. There are some other minor things in there, but it's mainly oxygen and nitrogen. So as you walk around, you're moving through a solution. Now, you can have water vapor in the air, like when it's very humid out, and that's also still a solution. Now it's a mixture of water, H2O, nitrogen, and oxygen. Now, other solutions, the one most people think of when you say the word solution is a liquid solution. Now, there are various things that are complex solutions. And if you like pop, and Dr. White likes Dr. Pepper and Werner's, I'm going to ask a polling question right now. Answer yes, did I talk about Werner's in here? Answer no if I haven't. Again, yes, I talked about Werner's. No, I didn't. Only one person voted. Where's the rest of you? All right, well, I guess you didn't. Well, it's a 50-50 vote. All right, I'm going to talk about it. Pop, if you're from Chicagoland, I've been born here and lived most of my life here, except when I lived 5 years in Michigan, where I went to Michigan State for my PhD. In Chicago, in Chicagoland, if you have in a can or a bottle carbonated beverage that's non-alcoholic, we don't call it soda. That's East Coast stuff. We call it pop. And one of my favorite all-time pops, I've been drinking for many, many, many years. Is this right here. This is called Werner's Ginger Ale, and it's a different ginger ale. It's really strong and it's very highly carbonated, and I love it. I have a couple of cases in my house, along with a couple of cases of Dr. Pepper. And the best place, the only place I really find it easily is in Jewel. By the way, I don't get any kickbacks. I wish I did, but I don't from Jewel. But anyways, Werner's is a complex solution. The liquid, as you see in that bottle, contains many things. One of them, water. Another one, because it has carbonation, carbon dioxide, CO2. It also has a sweetener, and it has certain flavorings. And those are all parts of the solution. Now, if you took salt and mixed it in water, you would have a solution. If you took sugar and mixed it in water, you would have a solution. And my tea is also a solution. It's a complex mixture of different things that tastes oh so good. Oh, I love blueberry tea in the morning, and also my vanilla almond. Now, you can also have solids as solutions. You don't think of that, but brass items are solutions, mixtures of compounds or elements. Same thing with steel. Same thing with the old mercury amalgam dental fillings, which they don't use anymore, because if you haven't figured out by now, mercury is bad for your health and other things. So when we have solutions, they can be a gas mixture, a liquid homogeneous mixture, or a solid homogeneous mixture. But most of the time, people think of liquids when you think about solutions, but it's not always. Now, let's go back to here, solvent and solute. The solvent is the component of the solution present in the greatest amount. All other components are called solutes, or the solute if there's only one, because the solute is a solution component that is present in a small amount relative to the solvent. Oops. I just thought of another complex solution while I'm writing this, gasoline. Next time you drive by a gas station, what they're selling is a complex solution of many different chemicals that make up gasoline, the product you buy. All right, I'll do the first one, then I'm going to let you have some fun too. And if we look at the problem, 3 points each, what is the solvent and what is the solute or solutes for a solution containing A, 5 grams of sugar and 100 grams of water? Well, let's refresh your memory. Solvent, the component of the solution present in the greatest amount. Solute, a solution component that's present in a smaller amount relative to the solvent. And therefore, I can say water is the solvent because it's present in the greatest amount. And sugar is the solute for the solution. There's only one other component besides water. All right, your turn. why don't you determine what is the solvent and what is the solute or solutes for a solution containing 80 grams of nitrogen gas and 20 grams of oxygen gas. Your turn. All right, I think everybody's done. Let's get moving. And the question is, which is a solvent, which is a solute of the solution, which we have a name for the solution, and we call that air. Air is roughly 80% nitrogen, 20% oxygen. And what's the solvent? Nitrogen. Why? Because it's present in the greatest amount. And next, what is oxygen? It's the solute. Oh, let's do another one. These are fun. And the question is, what's the solvent and solutes for a solution containing 50 grams water, 75 grams ethanol, and 5 grams of sugar, otherwise known as something dangerous to drink? And don't forget, if you're done, be patient, because I try and give everybody time to think about things we're working on. Am I nice or am I nice? Don't answer that. All right, I think everybody's done. Let's take a look at this. Now, most people always think water is the solvent. Wrong. In this case, ethanol, which is present in the greatest amount, is the solvent. And the other components, sugar and water, are the solutes. Remember, solvent, component present in the greatest amount. The rest of the components are called solutes. All right, let's continue. Now, water is probably the most important solvent in many things. Not always, but mostly. And we call that a polar solvent. And that's due to polar bonds. Now, instead of a pair of dots, I'm going to use a line for a covalent bond. Here we have a water molecule. Because the difference in electronegativities, hydrogen is slightly positive, oxygen is slightly negative. This means lowercase delta slightly or a little. So it's polar because it has polar bonds. And it forms hydrogen bonds, hydrogen bonding to molecules with oxygen, nitrogen, or fluorine that has a hydrogen on this. And oops, I forgot to be subtle. Also, I thought I changed. Let's try this again. You should know this. So water forms what's called hydrogen bond to other polar things. And if we had another water molecule, notice the oxygen has a slight minus charge. The hydrogen has a slight positive, and there's electrical attraction, called the Coulombic attraction. And that attraction is not a full chemical bond, but this is called a hydrogen bond. I wonder if I can write this any smaller so you can't read it. And you should know that. And water forms hydrogen bonds to itself and other molecules. And example of molecules that can form hydrogen bonds, alcohols can, you should know this, hydrogen fluoride and ammonia. These are all molecules that can form hydrogen bonds with water. And I guess I could put down, don't forget, water is the most important polar compound in our universe. Now I'm going to turn the switch off. Have you ever wondered what happened? All right, there's water in here. And if I were to put some salt in here or sugar and go like this and shake it up, and it would still be homogeneous, same throughout, you tasted it, ooh, that's salty, or if with sugar, ooh, that's sweet. And how does the water molecules combine with the other molecules I put in here, which is called dissolving it? Well, water molecules have hydrogen bonds, and you have to break some of those. They're not a covalent bond, but they're a force to be reckoned with. Ooh, that's a fancy term. And hydration, which is how you dissolve things in water, is the process in which forces are broken in the solvent. And also, if I put in solid sugar or salt, there are forces between the molecules that form a solid. Those are broken. And then what happens is hydrogen surrounds the ions with water molecules. Or can hydrogen bond to the molecules you're putting in there? So when you dissolve something, you break some forces and you make some new things, and we call that hydration. Again, switch was totally off for this slide. All right, now I have to be real subtle now. Let's talk about the concept like dissolves like. And notice this little hint, know this, it's important. And like dissolve like is not a law, but it's a rule of thumb. And a rule of thumb is it's something that's true about 95, 98% of the time, but not 100%. But essentially, most of the time, it is true. And like dissolves like means like solutes are soluble in like solvents. And what this really means is polar solutes are soluble in polar solvents, and nonpolar solutes are soluble in nonpolar solvents. Wow, I even have it written on this slide. Know this. Now, here's something you should know. First of all, let me get the right color. What are substances that are polar? The most polar thing is ammonia. All salts, like sodium chloride, sodium fluoride, are polar. All alcohols are polar. An example of an alcohol, which you don't know about, but I do, it's not the alcohol that will get you inebriated, is sugar. Now, what are things that are nonpolar? Well, nonpolar would be gasoline is nonpolar, vegetable oil is nonpolar, and Vaseline, petroleum jelly, is nonpolar. So is baby oil. And something you don't think about, but we'll talk later in the semester, dirt and grease are nonpolar. So you should know these. And this will not be an important information. Oh no, I just looked at the clock. Sad news, everybody. We're out of time. I'll have to continue this on Monday. Quick announcement. On Tuesday, before the lab, I will go through the gas chapter, chapter 6 problem set. Make sure you do the problems before I do. Otherwise, you're going to get very disappointed with your score for test number 3, which you don't want. Guess what? I don't want. With that, have a great and wonderful weekend. I'll see you on Monday. Gehen gesund. Goodbye now.